we have a great opportunity tonight. We're very fortunate to have Tim Russ as our guest speaker tonight. I know most of the people, I'm guessing, who are in our audience have no need of an introduction. We have a lot of people in our membership who are big Star Trek fans and know Tim Russ by his character of Tuvok. And but I'm going to give you a little bit of a formal introduction. Tim Russ is an actor and a musician. He's also a screenwriter, a director, and an amateur astronomer. Most importantly for our meeting tonight, he's an amateur astronomer, and Tim is going to share his experience with us. Obviously, he's best known for his role as Lieutenant Commander Tuvok on Star Trek Voyager, but he's also been in several other series and had actually reprised that Commander Tuvok role on season 3 of Star Trek Picard. With that, I'm going to turn over the meeting to Tim, and we're really glad to have you with us tonight, and really excited to hear about your astronomy journey, Tim.
Pleasure to be here. Thank you guys for having me on board for your meeting. I just wanted to say that I started my journey. People ask me, what inspired me in particular to start the hobby hands-on when I did. This was roughly 35 years ago. And it wasn't anything specific. It wasn't like somebody took me by the hand and showed me telescopes and took me out and showed me how to use them. I just was always interested in space science. All the way through my teens and 20s, space science always fascinated me. It still does today, obviously. And I just decided one day that I would go out and I'd buy a relatively small telescope. It was a small, short tube, wide field mirror, which was an Edmund Astroscan. You guys, I'm sure, are familiar with it. And I took it out, and it wasn't even in dark skies. It was just in the city. I wanted to take a look at the moon and some stars and even a couple of planets. And when I did that, I saw Saturn for the first time. I thought it was absolutely amazing, blew me away. And from that point on, I was hooked. And then, proceeded to do what others might do when they're pursuing this hobby, is to go out and end up buying larger telescopes. So I went out to dark skies, which in LA, that's an hour and a half, hour and 45 minutes of a drive to get to the mountains where there's no city lights, and started learning the night sky on my own. And at that time, there was no cell phone. There was no computerized consumer brand telescope at the time that I started. They had a couple of them that were pretty expensive that would track, from east to west. But that was about it. There wasn't anything really sophisticated at the time. So the next telescope that I got was a little bit larger. I think it was a Schmidt-Cassegrain, or it was a refractor. It might have been a large refractor. But I just kept accumulating more telescopes. I had to learn the night sky and the constellations and all the major objects that were in those constellations by memory, and using a star chart at the time. I think it was, I also had Telrad charts because I was using a Telrad on the Dobsonian that I had. So learning where these objects were that were certainly bright enough that I could actually see them. They weren't something that was, when I look in the eyepiece, I could barely tell what it is. I usually went for the targets that were fairly decent in magnitude so I can see them in the features of them, and that they were more impressive in the eyepiece. So I did that, learn the sky, learn where these objects were by heart for the most part. Yeah, there's the Telrad. And went through over time, just accumulating different types of telescopes in order to look at different types of things. And the one thing that I really enjoy about the hobby in particular, what drives me really, is are the special events that occur. So when I was starting out, I had a pretty decent sized refractor, and I was up at Griffith Observatory on the day that the Jupiter collision took place, Shoemaker-Levy 9. I was able to see, the spots on the surface of Jupiter with just, a medium-sized refractor, and I was just blown away to be able to witness that. And the comets that have come in that were super bright at the time, I think there was Hyakutake, later on Hale-Bopp, and those were just magnificent in the Dobsonian. I mean, just spectacular in the eyepiece of just a 10-inch Dob. And to be able to see those moments, the close approach of Mars 17 years ago, not the most recent one, that was a complete wash, but the one before that was absolutely remarkable. I was able to see the surface features of Mars easily with even a 3.5-inch ETX, Maksudov. And so to be able to witness those special events, waiting for the nova in Corona Borealis, hope that happens soon, because I want to go ahead and image that as well. The comets when they come around and things like that. So to be able to have the equipment to be able to observe these things is just, to me, remarkable. And to be able to have a chance to observe these things and when they happen and have the tools to do so, to me is really the highlight of pursuit in this hobby. And that's basically where I am. So I've come this far up to the point where the technology has grown and has evolved to the point where the equipment that's available to us as just consumers, are just spectacular. So I represent the Unistellar EV scope for their company. And the Unistellar is an imaging telescope. I don't have a picture of it here, but it's called a Unistellar EV Scope 2. It is a relatively small telescope, not that big. It's got an eyepiece built in. It's a 4.5-inch mirror, 4-inch mirror, and it has digital magnification. It can filter out all the city lights, so you can use it in the city. It's a layer stacking process. So it just stacks the light really, really fast. Within 3 or 4 or 5 minutes, the object that you're looking at can come in. These are deep sky objects, not really super bright. It'll do planets and the moon and all that, but that's not really what it's designed for. It's designed for deep sky objects, galaxies, nebulas, things like that. I'm going to show you some of what this telescope can do. This is an example. It has GPS built in, so it sends the GPS. It talks to the cell phone, so it knows where it is. It has a location, so there's no 2-star alignment. The telescope, it just needs a star field to see, and it aligns itself in about 10 seconds. It could not be easier. My learning curve is a rock with a light switch. That's what I prefer. I don't want to go to get an engineering degree to use the telescope. It's very simple and very basic. And there's plenty of support online and forums and things to be able to, videos and things to show you how to use them. The Dumbbell Nebula is an example here. This telescope can pick up the color of the nebulas as well. And if you leave the telescope on this object using the enhanced image feature, stacking the light, you could stack it for a long time and it will get brighter. It will get more detail over time. But if you're just doing a public outreach star party and people want to look in the eyepiece, it takes about 3 or 4 minutes and they can look in and see this object with their eyes in the eyepiece. And that is what it's all about, really, when it comes down to public outreach and things like that, using a telescope rather than them looking at a monitor, a screen on a computer. This is the Andromeda Galaxy, which I'm going to be looking at that probably, was it next weekend, I think. Andromeda Galaxy, again, it doesn't take hardly any time at all for this image to come in. Because it's so bright and it's really a beautiful image. The next one I think is I have here. This is the Eagle Nebula. And as you can see in the center of that nebula, you can pick up the pillars of creation that the Hubble imaged very, very close, of course, much closer than this one. But you can get that kind of detail with this telescope. And I'm very, very fortunate to have an opportunity to be able to use this telescope today. It's leagues beyond anything that I had when I first started out. So I'm very, very happy to have this type of telescope. It's remarkable. And It's only the beginning. They've already come out with a new model this year called the Odyssey. There are other companies that are competing with them. Celestron's got one called Origin, although I don't think it has an eyepiece. I got to double check. It might, it may not. I don't know for sure. The key to me is the eyepiece. It's a telescope. It's got to have an eyepiece. But everybody's going to come running to make these kinds of telescopes. They're only going to get better. We don't have just one iPhone. It's iPhone 12, 13, 14, 15. So it's going to be these telescopes over and over and over. They're going to keep making them more sophisticated, more powerful, much better. And we as consumers are going to be able to just plop these down in our backyards in the middle of the city of Los Angeles, where I am. When the light levels is ridiculous in terms of the gauges. So it's wonderful to have this opportunity to use this. This is I think this is the fireworks galaxy. Of course, the longer the exposure, the more stars you get in the background. It picks up all this stuff. Does wonders on the galaxies. Really, really nice images as well. Some of my favorite stuff are the galaxies. What's the next one? We have, that's a globular cluster. There are quite a bit of them here in the summertime, so we can, I pick up a number of them. This is M22. I've done M13 and the other one as well. So they look spectacular as well. The longer the exposure time, the more detailed you got. This one, I think, was only 92 seconds. You can see how bright it is in 92 seconds. So, and the detail you can pick up. The next one I have on there is, this was one of those special events also that I was talking about. This is the Pinwheel Galaxy, and that's the supernova that was visible in that galaxy for about 3 months, I think it was, not long ago. I think the beginning of the year, and I was able to image that supernova. This was from my backyard. I didn't have to go in the dark skies to get it. As you can see, it's brighter than it outshines the entire galaxy in terms of brightness. It was fascinating to be able to zero in on that galaxy and actually pick up the supernova. That's a special event, man. That's a rare thing to be able to see, and this telescope is able to do that. The next one, Comet Neowise, wonderfully bright comet. You can see the corona is that beautiful corona on it, and the tail is spectacular. I've imaged about 2 or 3 other comets as they've come by since then, but they are not as bright as this one. They weren't as spectacular as this one. I was very happy to get this one on board. The next image. This telescope will also track asteroids, and that is asteroid Nereus, which is a near-Earth asteroid. And they have a list of objects built into the database that you can pick up and follow, through the citizen science program, which is attached to this company. And they'll give you the coordinates of the comets or the asteroids that you can pick up, near-Earth asteroids, and it'll track them. It's a series of 40-minute exposures, and then you download all the data from the telescope, send it to the company, and they will crunch the numbers and send you back a video of the 3 different exposures to put together a movie. And that's the movie right there. So it's fascinating to be able to do that as well. Mind you, it'll also do the light curves for exoplanets. You can actually track exoplanets with this telescope. They are much longer exposures. They're hours long. But once you crunch the numbers, send the data back to them, they will send you a light curve of that exoplanet transit. It will do that as well. The next one might be, this was a project that I worked on through the Citizen Science program, which was doing an occultation, the asteroid crossing in front of a star and blocking the light out momentarily, for the Patroclus, which is a Trojan asteroid that the Lucy mission that NASA launched recently is going to be checking out with their probe. They asked us to image this occultation so they could get an idea of what the shape of the asteroid was before they actually get to it. And it just so happens that the shadow that was being cast on the Earth when that asteroid crossed the star, it's a tiny, tiny eclipse, was right over Los Angeles. So I was here, I took it out to the park next door, and I went ahead and it was a 4-minute exposure. and got the numbers, crunched them, send it back to them, and they sent me back the movie. As you can see, as this plays, the light curve is on the bottom, and as the light curve dips down, the star light disappears, and then the asteroid comes back. And that's just this very tiny, tiny light curve as the asteroid crosses in front of the star and blocks the light of the star. And that is the occultation. That is what they asked me to image. And myself and others did the same thing. And they basically combined all the data from all the telescopes, and they decided, and they gave me a shape, approximate shape of what this asteroid looks like. It was kind of a flat oval shape and beveled edges and things like that. It was very interesting. They made a mold for me. I actually saw it. So it was very cool. And this is, again, what, if you have this telescope, you can participate in the citizen science programs. Everything from near Earth asteroid tracking to they'll let you know when there's a transit for exoplanets. They'll let you know when what comets are close by or coming in. All those things, all those special things. So again, looking forward to the supernova here in that's in Corona Borealis that hopefully will be soon, and I'd like to be able to track that as well. I think the next image I have is just of the equipment I was talking about before. For people who might be starting out, this is a very good telescope to begin with. It's very inexpensive. The company Orion is not in business anymore, but you can find these telescopes or companies that are reputable that make a very similar size telescope and the style of it. They're out there, and they're very inexpensive. These are Maksutov Cassegrains. I really like these telescopes. Very small, super lightweight and portable, and very powerful for their size. These scopes are very powerful. These come in at around 1,200 millimeters focal length, and you know they're only about that big. So you can pop that right off the tabletop base and put it on a regular tripod. It has dovetail, so you can put that on a tripod that's got slow motion controls or even a motor drive with a dovetail attachment. Once you get it, so that's a good setup. And I've got the next one. I think is this is a little larger, 100 millimeter Maksutov Cassegrain, and it comes with the equatorial manual tripod. You see the worm controls there, which make it a lot easier to track. It's a pretty sturdy tripod, and that's what you need all the time. I like the Maksutovs. I have a 5-inch. This one I think is a 4-inch. I have a 5-inch. I had a 6, but I use a 5-inch every once in a while, and that's I use it all the time for looking at the planets, the moon, and the stars. It does a wonderful job for that. And that whole package there is like $349 on Explore Scientific. They're very good telescopes. I also have a Skywatcher that I use with a manual tripod. I have a tracking tripod. I use it sometimes. Sometimes I don't. Sometimes I just want to throw it on the ground and just put it on and just go. I don't want to futz with all the programming and everything else. But it's all available out there for a price. What else is on there? That's a Dobsonian. I have a 10-inch Dob at home. It's an old one, Meade. I've had it for 100 years. And it's a good old standby for dark skies sometimes if you just want to do some naked eye observing. Dobsonians are great because they're the only telescope design that looks straight up and down. Almost all the other telescopes don't like looking at zenith, straight up and down. And the only one that does it very well is a Dobsonian. So if it's right overhead, you can look straight up and down. It's a lot easier. Throw it on the ground with the base, put the telescope in the base. There's no motor, no batteries, no cords, no cables. Grab the top end of that thing and wheel it around, and you're off to the races. Wonderful telescopes to start with. You can get a 6-inch, 8-inch, 10-inch, all the way up to 16 if you want. You'll need a big RV or something to carry it in, but you can put a 10-inch in a car and get it all in there without too much trouble in the trunk. It's not bad. Next, I think I had was just the Telrad, which is what I use for finder. Most of the telescopes that they'll fit on that they send to you don't really have decent finders from the factory. They give you the red dot finders, which are really not very good. I just take those off or don't put them on at all. And I just use this Telrad, which are standard. Most of you guys know about it and have probably used it. These are great finders. You can get it on a Maksutov that's about 4-inch diameter or larger. The ETX probably is a little too small for it because it's about the same length as the whole optical tube. But these are fantastic. 3 screws to align them. It's got a dimmer switch. It uses 2 AA's, which last 100 years. It's got a bullseye reticule inside that's lit up that you can see against the night sky, and you can dim it down or brighten it up. They're so easy to use. They're very stable. Once you have them lined up with your telescope, they're not going to move around. So they're very good. The next one is, I think, the Rigel. The Rigel has a shorter base, so you can put that on a short tube telescope. Same principle, basically. 3 screws to adjust the illuminated reticule. It has a bullseye inside, a red bullseye through that glass, and it has a dimmer switch on it as well. And this one uses, I think, 2032 batteries, not AA's, 2032, the little discs. And I do use this one on my ETX because the Telrad is too big for the ETX. So these are really good, very reliable, and they're not too expensive. Finders are magic for people who are starting out. Finders are really key. The hobby is not much fun at all if you can't find the object that you're looking for. So if you're frustrated about that, it's good to have a solid finder that works really well. You can get some of the red dot or red circle finders that are out there that are different than these, but make sure you spend, some decent money on them, because otherwise they can be very frustrating to align. You have to align the object with what's in the eyepiece. It's got to be centered in the eyepiece and be able to see it in the night sky. And these 2 finders that I showed you, you can see the background night sky. You can see the stars along with the target. So you can see where to put the target. So these are very good to have. I think that was all I had on the pictures. Yes. All right. So did you guys want to open up to questions?
Sure. If you would like to ask a question, I appreciate it if you could either put something in the chat or raise your hand, and we'll get you in to talk to Tim. Okay. That assumes I can see everybody. That hang on. That didn't work. Stephen, how are you able to do that? I've got the wrong view here. Okay.
Well, I do have yeah, so I can't see everyone at once, so I don't know how well the hand raising is gonna work. But
All right. Well, okay. So we've got a question from Hal McKinney.
Okay.
How long does a supernova last? I don't know. Tim, you want to take a crack at that, or
It depends. Yeah, it depends. If it's like the one that was in Pinwheel Galaxy that I imaged, I think that supernova was bright for about 3 months, 3.5, almost 4 months. If it's a genuine supernova, which is an exploded star, it'll last for a while. This one that we're waiting for in Corona Borealis is only going to be a few hours of brightness because it's not an exploded star. This supernova in Corona Borealis that we're waiting to snap, as it were, to pop, is a white dwarf star that has a binary system with another star that's larger, and it is feeding on the plasma from that star. And as that plasma winds around the white dwarf, it builds up and builds up and builds up, and then finally it explodes. And it just does this on a 75-year, I think it's a 75-year cycle. So they're expecting it to go off very soon. They were hoping September. I don't know if it's going to happen in October. Maybe it'll be October. But that type of supernova is a type 2 supernova, I think it's called. So it's not an exploded star. It is the result of a white dwarf that's been feeding off of a larger star that's right next to it. And that star is feeding the white dwarf with plasma, and that stuff builds up, and finally it snaps. So it's only going to be visible at about 2 magnitude 2 for about, I don't know, 4 or 5 hours maybe. And then it'll be magnitude 10 for a couple of weeks or something like that. So it's not going to be that bright for that long. And I'm hoping I can get a chance to see it.
Okay. Cora, do you want to come off mute and ask Tim your question?
Yeah, sure. So, Tim, I'm amazed on all the telescopes you have. It's unbelievable. I missed you talked about the Unistellar telescope, and I missed the model. Was that the V scope, or which one do you have?
I have the EV scope 2.
The EV scope 2. Okay.
Yes. And I believe the Odyssey is what they came out with this year. It's the tube is even shorter in length. It does basically the same thing, and I can't remember if the Odyssey has an eyepiece on it or not. I think it does. And the Odyssey, I believe, is a little bit less expensive than the EV Scope 2. But again, the images are very similar. I've seen some of them from there, and they're very good. So it's basically, these telescopes fit in a backpack, which it comes with, actually. So it's a backpack, it's a tripod and a telescope. There's no finders, there's no eyepieces. That's it. Telescope, tripod, and your cell phone. That's it.
Right. Great. Okay, thank you.
Hudson, you want to come off mute and ask your question?
Oh, sure. I had a question about the EV Scope 2 also. Is the eyepiece that's on it digital, or are you looking straight through the scope?
You're looking at basically it's a Nikon eyepiece, so you're looking at an image from the processor, so that as it's doing the layering and stacking, that's being transmitted to the eyepiece. So it's not like a glass eyepiece you're looking through the light and the mirror coming off the primary and secondary mirror. It's the image coming off from the software, from the processor that's doing the stacking, the light stacking. So it's kind of a combination of both, but it's mostly that. So you can look at an object with, like I said, for example, the planets without using any of the imaging software and see the planets. It has digital magnification, so you can get up on them. But if you wanted to get even more detailed, if you wanted to image the planets, you have to turn down the gain on them, so because otherwise they're too bright to get any detail. And so I've done some imaging on the Saturn and some other stuff. It's okay. I think that the naked eye through an optical telescope is always going to be better for the planets and the moon. But yeah, so it's a very specialized eyepiece. These guys, it took some time for them to get this design together. It was like 2 years for them to be able to get the money to build it and make it work the way it does. It's fascinating. It's absolutely fascinating.
Yeah, thanks. I have
Okay,
a Sea Star. It's pretty cool, but
Yeah.
similar.
Okay, Hal McKinney, you want to come off mute? Hal, are you there? Okay, Brian Kudnick, you want to ask your question?
Yeah, good evening. As I was watching I actually was more recent in getting into the Voyager series. They have it on the Heroes and Icons channel, and about several years ago, I watched the entire series. Have you ever thought about what it would be like to actually go to the parts of the galaxy that Voyager was that visited, and what the sky would look like from those various parts from 70,000 light years away and 30,000 light years away?
Wow. Yeah, I imagine being able to travel just about anywhere in this galaxy all the time. Fortunately for us, we're able to, now be able to peer into all the corners of this galaxy and out into the universe because of the telescopes that are available to us through NASA and JPL. And so we are living in such an amazing time right now, today, right now. And even in the coming years, I just met with one of the guys from JPL. As a matter of fact, he was the program manager for the Kepler telescope. He actually was in charge of the Kepler. And I just met with him for lunch a couple of days ago, and he's talking about what's going to be coming online very soon. It's just stunning what they're going to be able to see. And I think that from that part of the galaxy, depending upon which part of the spiral arm you're in, because the Earth happens to sit in between the spiral arms where it's really, really busy. Fortunately for us, fewer stars to go supernova close by, but it depends on what part of the spiral arm of that quadrant you're going to be in, because it could get really busy and crazy if you're in a really dense part of the galaxy's spiral arm. So it would be absolutely amazing to be able to witness some of the things out there, especially firsthand.
Fascinating.
Okay, Michael Rapp.
Sure. Tim, when you were working on your various acting projects and TV series, did you find the intense filming schedule getting in the way of your observing more than you'd like?
Not too bad. It wasn't too bad because most of the observing I did was going to be in the evening. So there were nights in which we had to work until 12 o'clock, 1 o'clock, 2 in the morning. Typically that was a Thursday or Friday. But generally on the weekends I had off, And, you know, during the weekdays, if I had a light day or a light week on the show, that episode, which happened to come a lot more frequently in the latter years of those seasons, I had plenty of time to take the telescopes out. Absolutely could do that. So it never really got in the way of my viewing. It was it was always possible to go.
Okay, Kathy Jones. Kathy, you want to come off mute?
I I just had a question about the telescopes. Were you able to like check it out for yourself uh, before, utilizing it, or did you have to go online to get it that way?
You're talking about the Unistellar?
Yes.
Yes, I saw the demo of the Unistellar up at Griffith Observatory. Someone brought it up there from the company, and they plopped it down, and I heard everybody chattering about it, so I went over to see what they were looking at, and I looked in the eyepiece and saw the Ring Nebula, and I almost fell over. So that's when I first was introduced to it, and I decided right then and there I was going to be getting one of those. I did reach out to the company once the telescope was available, and they wanted to give it to me to represent, to promote it, because I'm always up at Griffith Observatory at least once a month with the Astronomy Club in Los Angeles, and we bring all of our telescopes on the front lawn of the telescopes, and it's open to the public, so the public can look at all the different telescopes and objects. And so I bring it up there all the time, and that's what I use to promote the telescope to public star parties. And so I had a chance to see it beforehand and in a demo right there on the same location. And it was 3 years ago, 4 years ago, I think it was. And I've never seen anything like that. So I decided I got to do that. I have to have one of these. If I had to purchase it, I still would have gotten it. I didn't care, because the what you can see and do with this telescope is absolutely remarkable, and their support is very good as well.
I see Hal McKinney was on again. We passed him by one time. Hal, are you still there? Because if not, I'm going to ask your question for you. Nope, I think you may not be on. Um, uh, Hal asked in the chat, are there any other legitimate astronomy buffs like yourself in the Star Trek universe, acting universe?
Yeah, not really. Some of my castmates were fascinated or interested in some of the things that I had seen and done, but they weren't by any means pursuing that hobby. I was the only one who was doing that, and I don't know about all the cast members from the other shows, but I know on Voyager there wasn't anybody that was seriously pursuing the hobby, at least on my show. It could be possible that the other ones were.
So Eddie K also asks, he says, glad you're back from the Delta Quadrant. What's a decent beginner scope for an 8-year-old interested in astronomy that will be good enough for them, but not too expensive in case the interest wanes?
Well, that's what I showed earlier. I would get him a small Maksutov Cassegrain, the little red one that I showed earlier, the tabletop. It's like a tabletop. And again, you can get a sturdy tripod if you want a manual, just a manual tripod, nothing electronic, no digital, no batteries, no cables. And you can take that telescope and put it on a manual tripod, so you can work it and control it a little easier. Alt azimuth, jets up, down, left, right, nothing fancy. That little telescope is a really good beginner. I still have my ETX, a 3.5-inch ETX. I still have it. It's, along with my other ones, I still use it every once in a while, because I just plunk it down, put it on the tripod, and go to town. And it's just simple and easy. You can travel with it to dark skies. And, if you want to do that, it's great. It's good for looking at the planets, star points, and the moon. Very, very good for all of that. You can put a sun filter on it, just a Mylar sun filter, preferably glass, not the material, not the flexible material, but a glass Mylar filter on the front, and look at the sun. See the sunspots. They're all active right now on the sun. And those telescopes are about 200 and change. That's it. Very, very good. Orion does sell them. Orion is not in business right now, but their telescopes are online. I think they're on Amazon. You can get them on Amazon. As long as you get the brand name Amazon, or you can go to Amazon, you can go to Explore Scientific, they might have one. You don't want to buy them from Costco or Walmart. You want to get a good brand name, telescope by a company that makes optical equipment, not those other things. The Maksudovs are the best. Also, Maksudov Cassegrain has a secondary fixed mirror, and it's also concave in the front, so you don't have an issue with dew collecting. If there's a dew point that's pretty low and you're outside, you don't get the dew. If you have a flat shield in front like a Schmidt Cassegrain, you got to have a dew shield put on it because it'll get dew on it and you won't be able to see anything. This concave kind of keeps that away on the front of the telescope, and the fixed mirror, secondary mirror, does it. You don't have to do any collimation on the thing. On a Schmidt, you've got to collimate that secondary mirror around it, after banging around or whatever. But in a Maksudov, you don't have to collimate anything. It's a fixed mirror, so it's always going to look the same. It's going to be sharp. It's a very good, very powerful telescope. You can get right up on the craters of the moon and you can see inside the craters. Inside the craters. So, I mean, that thing is spectacular. It's a very good telescope. You want to do some birding with it, you can do that too. You can put a 45-degree prism diagonal on it and you can look at birds. I mean, there's a way to go with that thing. It's all great.
Debbie Moran, you want to come off mute?
Hi, Tim. I was just wondering if you have any interest in space tourism now that it's becoming a reality, and if so, would you want to go up at night or during the day?
Space tourism. You're talking about on one of Elon's rockets?
Well, that would be out into orbit, or suborbital would be Jeff Bezos's rockets or Richard Branson's rockets.
I think orbital would be very cool. If I had a chance to do it, sure, I would take the opportunity. Absolutely. Yeah, why not? It would be fascinating. I would like orbital as opposed to suborbital. I'd like to be able to go around once to see a thing. That would be fascinating. Yeah, that would be great. When I have my $1 billion, I'll think about doing that.
Yes, it does cost a lot unless you get
Oh,
someone
it
who's
cost absolute fortune. Yes, absolute.
I think the point is that it's starting to happen, and you got to get it started someplace before it becomes available to everybody eventually.
Absolutely. Yep. Yep.
All right. And any other questions you want for Tim? Just go ahead and come off mute.
I'm off mute.
Oh, Craig, you are there. I
Yes,
didn't
I'm
see
here.
you online. Go ahead.
Tim, one way we could visit some of these places that were in the Star Trek universe would actually be viewing them, observing them through a telescope. And I was wondering, are you aware of any list that might have the various places named and located?
You mean from the Delta Quadrant, as it were?
The Delta Quadrant, or even the previous series as well. I think I've seen at least one of the stars, but I can't remember which one it was.
I think there were a couple from the original series.
Yes.
That we've actually been able to observe. I don't know if there's any from the Delta Quadrant or not. I know that, well, Webb could certainly find it very easily, and so could Hubble. But I don't know of any that by name that that are just offhand that have been identified. Somewhere, I'm sure on Lord Google, there's going to be some information on that. I have not looked it up, so I can't give you firsthand knowledge of any of that.
And it's I'm not quite sure definition-wise where the Delta Quadrant was, but if it's on the other side of the core,
it's on the other
hopeless as far as an amateur.
Yeah, it's on the other side. It's I think it yeah, if you ask, it definitely is on the other side, the far side, the other side of the galaxy. So you got to it's a long haul to get back to where we are, for sure. It's not right next door. Yeah.
Okay.
So I have a question, Tim, as well. When you do your outreach events at the observatory, Do you end up seeing a lot of younger people at those events, and do they recognize you as your Star Trek character, as Tuvok?
Yeah, there are people of all ages at those events, and from I don't know how many different countries that are there, because there's mostly tourists. So and families and things like that. So there's all kinds of folks there, and they once in a while I do get recognized. Yes, that does happen, even when it's fairly dark out. Um, and some of the young people, if they're there, it's more likely they might recognize me from the Nickelodeon show iCarly, because I did I don't know how many years on that. So it's either one of those two. Yes. Yep.
I can just imagine that's a nice surprise for somebody not expecting it.
That is true. Yes, they're not going to be expecting me to be standing up there with a telescope on the front lawn of the observatory, in a public star party. Yeah, they're not going to expect that.
Okay, we're starting to get some Star Trek questions that coming in. Are you okay with those, or not so
Yeah.
much?
Yeah, that's fine. That's fine.
Oh, okay. Um, Kathy Jones, you want to? Oh, I'm sorry, Matt Borland, you want to come off mute? Up, maybe not.
Well, yeah, there's a little bit
Oh,
of
there
echo
you
here.
there you go. Okay,
So
ahead,
I was
Matt.
wondering if you have any movie recommendations of that do justice to astronomy, but are maybe lesser known. We've seen Contact and Cosmos; those were really great. So since you're in the scene, what are the movies that we typically missed out on, but are really interesting if you are interested in astronomy?
The series Three Body Problems, fascinating.
Yeah.
That thing is amazing. It's incredible. I mean, obviously it's based on a book that's been around for a while, but what I thought was particularly interesting about it is that they had to come up with a concept to make communication instant between Earth and this alien civilization that was on its way, and they're 400 light years away. So how do you communicate, instantly, as opposed to waiting for the message, to get there 400 years later? They had a way of communicating instantly with Earth and even monitoring Earth from that distance. And they were using photons. It was a way of using photons as a means of communication. Now, I'm still not sure that would actually work, but the photons is what they were using to manipulate, to communicate with Earth in an instant, like right now, over that vast, vast distance. I thought that was fascinating. I don't know if the actual science would actually, apply to that, if that's a theory or a concept that could work, but that was amazing. And they were kind of basing it on the Proxima Centauri system, Proxima B, Proxima A, which is our closest stars to Earth. And I think that they were talking about, the gravitational forces involved in a planet that's surrounded by three stars. The three stars are orbiting each other. Everybody's orbiting everybody, and what kind of chaos that could potentially cause. So, and my God, they're still looking at Proxima right now, pretty darn hard, as it were. I don't think that there's a gravitational issue with the planet that's surrounding the the red dwarf. I think it's Proxima B that the planet surrounds, the Earth-like planet similar to Earth. It might be a rocky planet. It's very close in the Goldilocks zone of Proxima B, which is a red dwarf. I think it's a red dwarf, and it's a very active red dwarf. The planet may be tidally locked, but I think orbit is stable. It's not flinging all over the place. It's not affected by the stars, the other two stars that are around, Proxima A and the other one, Centauri and A. So it's not affected by those. But the concept of three body problem was about the orbital, velocity, the orbital paths of the three stars and the havoc that it created with their planet. Interesting. Yeah, I thought it was a really good series. Fascinating series.
Okay. I think we are getting to about the end of the questions. I'd like to say on behalf of the Houston Astronomical Society, Tim, we really appreciate you spending your time with us. You know, it's very cool for us to know that you're one of us. I mean, how cool is that, right?
Yes, it worked out that way. Thank you. Yeah, it worked out.
Being an amateur astronomer kind of sets you apart from a lot of people, but you know, it's really cool that we can relate and know that you're one of us.
Yeah, and glad to be so. And I will be for as long as I can. We're in the age of discovery right now, which is
Absolutely
phenomenal, just phenomenal. I'm waiting for all of the bigger telescopes to come online, the next generation of telescopes to come online, and to be able to see what Chris was talking about. Chris Davison is the project manager for Kepler that I spoke to a couple of days ago, and he said we shouldn't be looking for radio signals for alien life, intelligent life. We should be looking for lights. You want to see lights because lights on a planet will be around a lot longer than radio signals. The technology, you've got to have lights in a civilization. Those will be around, even if that civilization is more advanced than ours. More than likely, there will always be lights coming off that planet. And that is something you could detect that would determine whether there was intelligent life or not on that planet. And the telescopes that'll be coming online will be able to detect lights on distant worlds. That's where
Okay.
we'll go.
I did get one last question. I think that's a good one. What social media platforms should we follow you on?
I'm on Facebook under my name, Tim Russ. My picture's on there, so you know you're on the right page. I am on Twitter as well, under my name or TR Vulcan, and Instagram as well under TR Vulcan and or my name. I do post some of the images and things I do on Instagram. Once in a while, I do them on Facebook and Twitter, but more on Instagram. And Facebook and Twitter is going to be a lot more socio-political stuff that I post. So it's not going to be more of that than there is astronomy. When I get some really cool stuff, I mean, I've posted stuff on there before, so I'm not going to repost it. If I get anything new that's more interesting, exciting, I will post it on there now and then, Twitter in particular. But Instagram right now has a lot of the images that I've shot over the last year or so. I haven't loaded up any new ones, but I probably will eventually. And I think the 2 videos are on there as well that I showed you earlier. But Facebook and Twitter is mostly mostly political stuff. You know, I'm 68.
Kind of the nature of those platforms.
Yeah, kind of the nature. And you know, I'm 68, so I've been around for a while, and I've seen a lot and lived through a lot, and I think by now I know better. So I tend to feel fairly passionate about the state of affairs in the country, and so I do post a lot of that stuff. You know, if things go south, it's going to be the scientists who are on the chopping block. Am I right? Right. So, you know, we got to score one for us. That's what's on there. So you have to take a look on Instagram. I do have some pictures on there. I don't have anything current right now. If I can get this supernova that comes up, I'll post that for sure. And I might add a few more things on there. Instagram's a little bit looser. I put all kinds of things on Instagram. So Instagram, yeah, Facebook and Twitter, I'm on there.
All right. Well, thank you very much. Again, I can't say how much I'm very pleased that you spent your time with us, Tim, and be well, and hopefully we'll see you in some more. I'd love to see you in more Star Trek stuff again.
Well, that's up to them, man. They gotta.
I know.
They gotta
I
make
know.
the call and make the invite, and I'd be more than happy to show up and do the work. Yeah, whenever it happens. You know, all
right.
of that is a mystery to
All right.
us, the universe.
Well,
Pretty
Thank
right.
you, Tim.